Hello everyone. In this video we're going to be solving a fantastic geometry puzzle. Ready? Let's go. 5 circles, one with radius A, 2 with radius B, and 2 with radius C are inscribed in a circular segment of a semicircle with radius R as shown. Find R in terms of A, B, and C. And we're given that C is the smallest and A is the largest radius. Okay, great. So what are we going to do? First of all, notice that the one in the middle, there's only one of it, right? Has the radius A. So the biggest circle has radius A. So let's go ahead and start with that one. I will be making a connection here. So this will be kind of meaningful, right? So let's go ahead and mark this as H. We don't know what that height is. And it's not being asked, but we do need it. So let's go ahead and call that H. This is A, and this is A. So, and we know that the radius is going to be R, so we're going to take care of that in a little bit. But let's make more connections. Okay, so I'd like to connect these two centers here, which will be important, right? Like this. Okay, and then I'll be connecting these two centers as well. Okay, as you know, when we do this type of thing, we're actually getting some important information. How? Well, this is A as well, and this is B now, and this is B. Awesome. And what do we get from here is actually I can kind of drop a perpendicular to make that more meaningful, and also extend this. I think it'll be more meaningful if I do extend it. That way you'll see what I'm talking about, right? Here we go. Okay. All right. So what are we talking about here? We're basically talking about this being B, and the whole thing is R. Therefore, this length is going to be R minus B. Okay. From this point to that point. Center to center. Okay. Awesome. What else do we know? Well, this is also H. And let's call this X. We'll find out what that is. Okay. But we do need more connections. Let's continue. All right, so we'll connect these, drop a perpendicular, and then obviously there's one more, right? And let's go ahead and do this connection here. And this will also be helpful, as you know. Okay, how am I going to use that information? The smallest radius is C. So this is C, this is H, and this is C as well. Great. Now, since from this point, actually, that's not accurate, right? So we would probably back up a little bit here. Let me go ahead and see if I can erase this. Okay. I was going to say, oh, I hope it doesn't erase everything, but kind of did, but that's okay. We can start over. So here's the thing. I want to make the connection from center to center. So I should go this way. And I kind of want to change colors here. Let me use a different color. Okay. To make it less confusing. So I'm going to connect like this, right? Okay, awesome. Now what do we have? We have that here, as you know, right? We have this length here being R, so this will be R minus C. Okay, cool. Now we're still going to drop a perpendicular there. So let's go down this way. Okay, awesome. And this is H again, and this is C. So I think I got everything I need, but we need to call this something. Let's call that Y. Okay, awesome. Now what we're going to do is we're going to take these, lengths and then obviously use the Pythagorean theorem, but there's a lot of work to do. So let me go ahead and do this as well so I can show you what is going on here. I'm going to be drawing a horizontal line here. So my goal is to calculate X and Y, right? So I need to know what X and Y are. And in order to be able to do that, I do need these lengths. Okay, awesome. And what are those lengths? Okay, let's take a look. These are right triangles, right? Let me go ahead and shade them so you can see better. This one and this one. And as you know, this is AB, this is B and C. So I actually got the hypotenuse, right? And what about this piece here, the height? Well, A is greater than B, so this height here is going to be a little piece, is going to be a minus b, right? And this little piece here is going to be, maybe change a different color. This piece here is going to be b minus c. Okay, awesome. So let's go ahead and start with those. So I do have a right triangle, obviously there, actually two of them, right? So what are they gonna look like? Well, the first one gives me a minus b squared plus x squared is equal to a plus b squared. So I'm basically writing the Pythagorean theorem in this triangle here, right? In this tiny triangle. And then I'll be doing the same thing here, which is b minus c squared plus y squared, which is the base, right, is equal to the hypotenuse, which is b plus c squared. Awesome. I'd like to start with these because these seem a little simpler, and then we're going to write more equations, obviously, right? Okay, let's go ahead and simplify this. You know our famous identity. If I subtract a minus b squared and if I subtract b minus c squared, what am I getting from here? Well, the first one gives me x squared equals 4ab, meaning that x is equal to 2 square root of ab. And the second one should give me y squared equals 4bc, and that means y is equal to 2 times the square root of bc. So x and y values in terms of a, b, c, I'm going to use those later. Awesome. I got that in place. Now let's go ahead and work on these two right triangles. And what are they? Okay, the first one is this one. Okay, and the base of that triangle is x. So I'm going to write x squared. Let's change colors here. X squared. All right. Plus, what is the height? The height is h plus b. Okay, h plus b. So it's going to look like this. And what about the hypotenuse? The hypotenuse is r minus b. Remember, we wrote that before. Okay, awesome. R minus b squared. Beautiful. So just bear with me because we're going to be working with lots of equations here, and everything is a variable. There are no numbers because we're supposed to find r in terms of a, b, and c. Okay? All right. We're going to be using the other right triangle now. Let's shade it. It's this one. Okay? Its base is x plus y, so it's going to look like this. X plus y quantity squared. Its height is going to be h plus c, as you see, right? C, senor. H plus c squared. And the hypotenuse is r minus c, right? That's been marked, r minus c. Awesome. So these two equations are somewhat similar. You probably noticed. Anyway, so here's what I'm going to do. I'm going to subtract these two equations, right? So let's see what that's going to look like. When I subtract, it's going to look like the following, and changing colors here again. Let's use white. Okay. So this is going to give me x plus y squared minus x squared plus h plus c squared minus h plus b squared. So I just like to, subtract term by term. It's kind of easier and it'll make our work, simpler. All right, awesome. Let's go ahead and simplify this as much as we can. We're going to get something nice from here. But again, that kind of looks complicated, but it'll simplify, don't worry. X squared plus 2xy plus y squared minus x squared plus h squared plus 2hc plus c squared minus h squared minus 2hb minus b squared, okay, is going to equal what? Okay, this may not fit all here, so let me go ahead and use the bottom row. And this is going to equal r squared minus 2rc plus c squared minus r squared. Notice that we're going to negate the second part. Positive 2rb minus b squared. Okay, let's go ahead and simplify this now because this is going to actually simplify a great deal. Okay, let's see. X squared cancels out. H squared cancels out. And what else? Okay, this part is important. R squared cancels out. C squared minus B squared cancels out from both sides. And what do we end up with? Some XY expression and then HC, HB, RC, RB. So here's my plan. I'm going to keep this expression on the left, and everything else I want to put on the right hand side. What do I already have on the right hand side? I have the 2RB minus 2RC, and I'll just bring over plus 2HB minus 2HC. Beautiful. But this is going to get more beautiful. All right? So now with the X and Y, I'm going to be doing something. So let's go ahead and do that. As you know, we were able to replace X and Y with something, right? So I'm going to go ahead and substitute those. Let's go ahead and do it. But what are they? Well, we said that, let me go ahead and copy those here. We said that X is going to be 2 root AB and Y is 2 root BC. Beautiful. So let's go ahead and plug that in. So this should give me 2 times X, which is 2 times 2 times root AB, times Y, which is 2 times root BC, plus Y squared, which is 4BC. Awesome. This is equal to, now, before I go any further, I'd like to simplify this. And I noticed that these expressions are factorable. I can take out a 2R, that should give me B minus C, plus 2H, that should give me B minus C. Beautiful. Now this is factorable by grouping, but let's go ahead and simplify the left-hand side first. This is going to give me 8. And then notice that the square root of B is multiplied by itself. That should make B. And then everything else, A and C, are under the radical. And it should look like this. Okay? Plus 4BC. Now I can put this together. 2R plus 2H. And then I could probably do the following. Why don't you just take out a 2, right? And that should give me, when I take out the 2, it should give me something nice. Oh, so it's going to be 2R plus 2H multiplied by B minus C. And then we can simplify this a little bit more. Okay. So what I can do here is continue. But we got to do one thing here, which is what? Now, we're trying to find R in terms of ABC, but what about the H? Should we have something for H? And we actually do. Remember that? At the very beginning, we were trying to, where is that expression? Didn't I do that? Oh man, I didn't do it. Okay, let's do it then. So what I have here is I have H plus A being equal to R, right? What is that supposed to mean? It means that H plus 2A is equal to R, which means that H is equal to R minus 2A. Awesome, so I got something for H as well. Beautiful. So what I'm going to do is I'm actually going to cut this because I don't want it here. And I'm just going to move it down a little bit. There you go. Awesome. Okay, because I need some room here. So let's go back to our color. Now, what am I going to do? I'll take out the 2, and then I'll write R plus H multiplied by B minus C. Awesome. But now I have something for H. I'm going to substitute that. Let's go ahead and do it. The reason why I don't simplify this yet is because wait till the end to see what happens, okay? So now, what am I going to do? Replace H with R minus 2A. I told you this is going to get more and more interesting. Okay, now let's see what happens. I get 2R minus 2A, which means I can take out another 2. So that's going to give me the left-hand side equals. Now, this is 2R minus 2A. And when multiplied by 2, that's going to give us a 4. Beautiful. And that's why I waited until this point, right? Okay. Now I can divide everything by 4. Isn't that awesome? It's simply awesome. Okay. So this is going to give me what? R minus A and B minus C. You guys might be thinking like, how am I going to get R out of this mess? Well, there's a really nice process to do that, and I'll show you in a little bit. So we're almost done. Just bear with me. Wait until the end, okay? All right, let's continue. So what I like to do now is, since I'm trying to get the R by itself, I would like to divide both sides by B minus C. Isn't that meaningful? B minus C is going to cancel out, and it's going to get us closer to R. So this is going to give me R minus A being equal to this guy here, which is 2B root AC plus BC divided by B minus C. Now what I'm going to do is I'm going to be adding A to both sides, cross this out, and I'll get my answer from here. But let's simplify a little bit. How do I simplify? Well, I'm just going to add make a common denominator numbers, right? So I'm going to go ahead and distribute this a times b minus c and all over b minus c. All right, let's do one more step and then just arrange this a little bit. I'm going to get ab from here, and then I have bc minus ac plus 2b times the square root of ac all over b minus c. And that should do it. So we were looking for the radius, right, in terms of what? A, B, and C, and we found it. Beautiful. All right, so that's our answer in terms of ABC. So what's really nice about this problem is that you can basically plug in any value for ABC and then find the value R. And obviously you can find H as well. Awesome. Thank you for watching. I hope you enjoyed the video. Please comment and like, and if you still haven't subscribed, please do subscribe. Hit the notification button so you will be notified of future events. See you in the next video tomorrow. Until then, take care. Bye-bye.